Okay, so this was the other example I was going to talk to you about. So at t equals 0, what is true? It is at x equals 0, and it has an initial positive velocity. Okay, so it's going through equilibrium that way, to the right. And so if we take our general solution, a cosine omega t plus phi, and we apply our initial conditions, so x at 0 is a cosine omega t, t is 0, so that's 0, plus phi. X of 0 is 0, so that equals 0. So the question is, a cosine phi equals 0. What phi is that true for? It's true for plus or minus pi over 2. And in case any of you are thinking 90 degrees, you're not wrong, except when we do this stuff, we are radians all the way, baby. All right, so just sort of remind you what your unit circle looks like. Here's that and that. So here's pi over 2, and there's negative pi over 2. So cosine, of course, is the x component, and so it could be 0 there or there. So let's delve a little deeper. Okay, so what else do we know? Let's look at v. V, of course, is dx dt. So we get negative a omega sine omega t plus phi. So if let's look at v of 0, v at t equals 0. It's negative a omega sine of 0 plus phi, right? So v of 0 is negative a omega sine of phi. So what were we told? We were told that v was greater than 0. So v at time equals 0 is greater than 0. So that means that sine of phi must be less than 0. So which guy gives you that? That guy right there. Boop. So that's negative pi over 2. So that means that phi equals negative pi over 2. So our official equation is a cosine omega t minus pi over 2. And take a moment and think about what that means. Okay, so here I wrote it again. So it's a cosine omega t minus pi over 2. So if you remember how sines and cosines work, I'm going to draw a cosine. And then, so all this means, because it's omega t minus pi over 2, all that means is that, maybe I'll get a new color. It means that this is going to be shifted by pi over 2. God, I'm bad at drawing. But I think you get my point. And my gosh, that is a sine. All right, so x of t is a sine omega t. And yeah, so actually now that I'm looking at this, maybe that was a little bit fast and loose with the shifting. It's probably shifted not by pi over 2, it's shifted by, your delta t is that pi over 2 divided by omega, right? Because there's this guy. But then when you put it all back together, you should get this. So anyway, that's how you use those phase angles, but for all intents and purposes, just knowing about your initial conditions, if it gives you cosine or sine, then you can rest easy knowing that that guy in there is always going to be omega t.